Hello, this is a video on the eliminations method of solving simultaneous equations. Okay, what I'm going to do is take you through an example and work it out and show you all the steps and say how they apply to which elimination method equation you want to solve, and then take you through a little bit of the intuition as to why it works. Okay, so let's get started. You've got for question A, x plus 3y equals 4. And x minus 3y equals 10. Okay, now when I look at using the elimination method of solving these equations, what I'm looking for is two numbers that have the same coefficient. Two letters that have the same coefficient. And here they both do. There's a 1 in front of the x, like not really, but sort of in our maths imagination there's a 1 in front of the x because we've just got an x, and there are 3's in front of the y. So we've really got two to pick from. Okay, but what I'm going to do is eliminate the y's. Okay, and the reason I'm going to do that is there's a plus here and a minus here. Okay, so that just makes the equation just a little bit easier. So what I'm going to do is add these two equations together. Okay, I'm just going to add one equation on top of the other. So when I add my x and x, I get 2x. Okay, when I add my 3y and then take away 3y, they cancel. They go away, they eliminate. That's the elimination method. So I've got nothing there because they've been eliminated. And then I end up with 4 and 10, which is 14. Okay, so now I've got an equation I can solve. 2 lots of x equal 14. So if I give 2 lots of x equals 14, I can just divide by 2 and divide by 2, and I get what 1 lot of x is, which should be 7. Okay, so now I've got my x equals 7, but the question is asking me to find both x and y. So what I do is I take my new knowledge that x equals 7 and I substitute that into the first equation. Okay, I substitute my new knowledge that x is the same as 7, so x and 7 are the same thing, thus this x must also be the same thing as 7. So I can rewrite my first equation, the one underlined in red, as 7 plus 3y equals 4. Okay, and again, this is a step that people struggle with, but all I'm doing is I'm taking my knowledge from down here, another circle just to show you where it is, and I'm putting it into the equation up here and saying that x is the same thing as 7. Okay, so what I do next is I look at my new equation and I solve for that. Okay, now my first job is to get rid of the 7. Okay, you always want to get rid of lone numbers by themselves first. It's generally a good strategy. Take away it from both sides to keep it fair, and I end up with 3y equals minus 3. Okay, now this is something that gives some people some trouble, but all I need to do is divide by 3. Divide by 3. If I've got 3 lots of y, I divide by 3 to work out what 1 lot of y is. And with y equals, now minus 3 divided by plus 3 is minus 1. Okay, and you're done. So that's the elimination method of solving simultaneous equations. Essentially, you add the equations together, and that is if there's a plus and a minus and the same coefficient. And then what you do is you solve for x, or whatever value is left over after the elimination. Then you substitute your answer into one of the original equations. Oh, sorry about that. Get to see what the day is. Ah! Okay. Now the reason this works is that in maths, people worked out that we can add equations and that we can take away equations and that they're still equal. Okay? Because, and there's going to be so many circles and highlights at the end of this, but this side of the equation, the one in green, is exactly the same as this side. Okay? And this side of the equation is exactly the same as this side. Okay? So when you add them, a green circle and a red circle are the same. The same thing as a green circle and a red thing that are the same. Okay, adding the equations doesn't ruin the equality, the equalness of the equation. And that makes this entire thing work. Okay, I'll go through another example in a later video, but hopefully that gave you an insight into solving, the elimination method of solving simultaneous equations.